In this video, we'll be talking about section 4.1, angles and radian measure. This video in particular is going to focus on the concept of angles and how they're built and what they're composed of. The first detail we have to understand is that an angle is created by two rays. A ray is nothing more than a line such that it has one direction that it continues on forever and one direction, one location where it stops, or what we would like to say start. So if I connect two of these rays together, this would create an angle. Now, it is important that we also include a specific direction of that angle. So in this case, this angle is moving in this direction, meaning that this side here is what we call the initial side, and this side here is the terminal side. We might also refer to them as the initial ray and the terminal ray. So I could draw another angle, the exact same angle, but then flip that inside arrow. It identifies that now this ray is the initial ray and this ray is the terminal ray. It's also important to note that these are two different angles. In the mathematics that we might have worked with before, they might have been the same angle because they had the same value. But now when we get into these angle measures, we're talking about different measures of angles, and anything that's measured counterclockwise is considered a positive angle, so that would be a positive angle. Anything measured anything measured clockwise is considered a negative angle. So I could draw more or less the exact same angle that's not necessarily in the same position as that, and then go ahead and draw the arrow going like this. This is technically the exact same angle as this one. It's just floating around in space, oriented slightly differently. It still has a positive angle because, again, we're traveling counterclockwise. So when we talk about most mathematics, we do end up referring to a quadrant system. So we're going to go ahead and start putting these angles inside this x and y coordinate plane. So I have the first quadrant, I have the second quadrant, I have the third quadrant, and I have the fourth quadrant. Now, hopefully you better understand why these quadrants are labeled the way they are, based on the fact that we move counterclockwise in an angle measurement format. So again, if I put a initial side here and a terminal side here, then this angle goes like this. Now there is a way that we can draw that angle backwards like this, but that's a different angle entirely. This is a positive angle, and it lands in the second quadrant. Again, notice that this is the initial side, this is the terminal side. So we can draw angles like this outside of the quadrants, but when we draw in the quadrant, it's more appropriately written, especially if I put the initial side on the x-axis. This particular angle would be referred to as being in standard position. So again, these two you could consider as being in standard position, but this one is not in standard position because we're not having that initial side. This actually isn't in standard position because its initial side is not on the x-axis, but this one would be. So this is in standard position, this is in standard position, and these two are not because of the way that we've drawn them. Now you have angles that can land in certain quadrants. So for instance, this angle I would say lands in quadrant 2. It doesn't mean that the whole angle is sitting inside quadrant 2. It means that the terminal side stops in quadrant 2. There is another form of an angle that we could call a quadrantral angle. Again, spelled this way, quadrantral angle. And a quadrantral angle is one that actually lands in between two different quadrants. So for instance, this right here, which hopefully you guys could recall as a 90-degree angle, that is a quadrantral angle. Okay, it lands on one of these axes and therefore isn't actually in any one quadrant. So now let's talk about the basic definitions of how we identify these angles. We can have an acute angle, and I'm going to abbreviate angle like this. And an acute angle is specifically 0 to 90 degrees. That means that it's not 0 degrees, nor is it 90 degrees. We can have a right angle, which sits in between the next two definitions. This it is actually equal to a 90-degree angle, while we can have an obtuse angle, which sits between 90 and 180. Now, it's important to note that I keep putting these degree symbols in there because these degree symbols will denote notation, specifically a unit of measurement. When we start to talk about radian measures, things are going to change drastically, and by leaving the degree symbol off, you are changing that unit of measurement. The last type of angle that we're going to talk about in this is a straight angle, and a straight angle is specifically equal to 180 degrees. There are other ways that we might refer to certain types of angles, but in all cases, an acute angle, again, is an angle less than 90. We have a 90-degree angle, which we normally add that box in there as opposed to an arrow to emphasize that it is 90 degrees. We have an obtuse angle, again, which is larger than 90 degrees but smaller than 180. And then finally we have the 180 degree. Now, the 180 degree angle looks like a straight line, but the way that we make sure that it's an angle and not just a straight line is by putting in that, again, angle measure with the dot for that vertex. So that basically defines what we should already understand as most angles, as well as provide some definitions for how we're going to refer to some of these angles and what positions they're in future videos.